Hello, audible?
Yes, sir.
Recently, this question was asked in your exam. Have we covered numerical on three-phase induction motor, correct? Yes or not? Three-phase induction motor question was in ETO exam, which was asked earlier. Not now. Okay, dear. Here. These are the questions from your ETO, old question papers. Like here, describe how the starting torque of electric induction motor may be improved by using wound rotor and double cage. Describe with add-on diagram an electronic soft starter that may be used for large AC motors. Discuss advantage and disadvantage of this. Correct? So this advantage is there is a gradually increase in voltage. So there is no jerk or stress on the rotor. Like in star delta starter, instantly your voltage is root 3 times is applied. Second, it reduces the starting current, smooth starting, like okay. Then we can by this now we can control the speed also with soft starter, because we by reduce the voltage by supply voltage control. But with other starter like DOL, star delta, we cannot use as a speed controller. Correct? But disadvantage is because here power electronics like thyristor, we use SCR. Huh? So means your harmonics will introduce. Okay, like VFD. Correct. And costly also it is as compared to DOL and star delta. Write a short notes on principle of operation. 6-pole motor supplied at 60 Hz with a 5% slip. What is the actual rotary speed? You can solve this, huh? It is very easy, huh? Okay. He is asking the rotary speed equals to synchronous speed into 1 minus slip. Slip is given here, 0.05. Synchronous speed with your 20 poles, no? 60 Hz. That is 120. F means 60 divided by 6. 6 to the 2. 1200 RPM. Correct? Synchronous speed. Explain the construction and working of three-phase induction motor. Explain the diagram star delta and their ladder logic diagram. Sometime they ask. There is a in first it is you have to explain the power circuit diagram. Explain how the direction of single phase motor, induction motor is reversed. So you know in single phase motor there is a 2 windings are there in single phase. One is a main winding. Other is auxiliary. Auxiliary. Okay. In this auxiliary, there may be sometimes a capacitor is also there. There is a capacitor is connected with a centrifugal switch, or maybe sometime it is a permanent permanent capacitor motor. Then there is this centrifugal switch will be not there. So it is a capacitor. Okay. This is your terminal, motor terminal. Phase neutral. In single phase we apply, okay? This is the equivalent circuit of your motor. Now this is your squirrel cage rotor. Okay. Here difference is only here stator has only single winding. Actually 2 windings. One is this is the main winding. Okay, main, and this is auxiliary. Okay. This is main winding. This is auxiliary winding. Correct. This is your rotor. Okay. Now, if we want to reverse, suppose in this case it is rotating in anti-clockwise, then how we reverse this? So by changing the polarity of either in main winding or auxiliary winding, direction of current. Okay, means if you change the here polarity, neutral phase, it will rotate in same direction. Only we change the polarity of any one, either this or this. Mainly we prefer auxiliary in which the capacitor is connected. So for this we use and there is a reversible switch. Suppose this is phase neutral supply. So here, this is your main supply we take. Here we put a 4-way switch. Okay. It is 2-way switch or it is reversible switch. Then this supply go to your feed auxiliary winding. This centrifugal capacitor and this. Next is this is your main winding. Okay. This is your router. This is your squirrel cage router. So here, by changing the polarity here, if we changing the position of this switch 1 and 2 like, then the direction of current will change here. Okay, suppose in first case in this here page this, and here in initially suppose this current is flow like this. Okay, then this motor is rotate this direction, but when this direction is reversed here at position 2, then direction of current is reversed like this. Okay, in this direction, then this is start to rotate in this direction. Like a DC motor also, how we reverse the direction? Either we change the polarity of armature winding or field winding. Okay, dear. Yes. Next question. Overhauling. Now this question, it is already we covered. This question was 7. We already cover in your. Okay. It is a synchronous speed. This is your speed rotor, and frequency when slip is 3%. Now this was very important. 8th. Okay. Let us discuss this. In 8th question, a 400 volt 3-phase 50 hertz induction motor. Hertz, 10 HP. 10 HP, okay. Induction motor, 3-phase, 10 HP. Induction motor. Star connected. Now we say that this has a no load slip. So suppose when motor rotated at no load, there is a no load slip. So as I told, no load, there is a low slip, means speed is higher. So now in one question they told now how the performance is changed from no load to full load. So at no load, the slip is low, motor speed is higher. Okay, then your rotor parameters means motor draw the low current, but at full load, high current will draw because when load we put the load, slip is increased, then motor draw the more current. Okay, so same here and full load. And at full load, what is the full load slip? 4% means 0.04. Find the following. First, you have to find the synchronous speed. Okay, it is 120 F by P. Very simple. Poles are here 4 pole, na? Here 4 pole. Okay. So this is 4. It comes means 1500 RPM. This is the motor rate, synchronous. Now he asked second part, no load speed. So at no load, what is the speed? Actually not, basically it is very close to synchronous, but at no load, it is not synchronous speed. Generally we take a very close means high, speed is high. It is 1 minus no load slip. It comes 1 minus 0.01 into 1500. Into 1485. Very good. RPM. Next, third part is full load speed. So at full load, what is the motor speed at full load? Now here synchronous speed, motor is same. Now we take here full load slip. Okay. So it is 1440. Fourth he asked rotor frequency at full load. My dear, when we calculate rotor frequency of rotor induced EMF, that is slip times of rotor frequency, supply frequency. But you know, my dear, he is asking rotor frequency at full load. So here we use a full load slip. 12. This full load slip is 0.04 into 50. So it get only 2 hertz. Then fifth is also asked full load torque. So you know motor output at full load. That is the rated capacity. Please, rated nameplate rating is the output. That is 10 HP means, you know, so it is 476 watt. This much is the watt. Okay, because 1 HP equals to 746 watt. Okay, so now you know, actually it is a shaft power output means full load torque into omega equals to 7460 watt, or it is therefore full load torque equals to N. N is your 24. Because this is speed at full load, na, it is in R. RPM. When we calculate our RPS, you divide by 60, so it comes 24 RPS. Okay? Because small n equals to capital N by 60. So now we can calculate torque. $49.49. It is in Newton meter. Or we can write 49.5 Newton meter. Okay, dear. Explain the phenomena of crawling and cogging. Three-phase motor wound for 4 poles, supplies with 50 hertz. What is synchronous speed, rotary speed? When this numerical we already cover, 9th part B. Correct, no? But now crawling and cogging, you know. Actually, already I share the notes in group, okay, pertaining to crawling and cogging, and I will explain. You know, actually, suppose this is the stator. You know, in stator there is a inner part. Here there is a slots, no? Here in the inner, like this teeth. That is called teeth. Stator teeth, like this. Okay. Same here in the rotor part. Here in the rotor. This is the shaft, rotor shaft. But in a rotor also there is a teeth, rotor teeth. Okay, rotor slots like this. Okay. So you know this part, this teeth, okay. Like actually when this rotor, stator and rotor opposite poles, like this is north, south, like this. So if this north pole and it is a north, south, here maybe north. You know, if this opposite polarity poles are face to face, then you know opposite polarity pole, there is a magnetic force of attraction. So means there is a magnetically locked this stator and rotor. Now suppose sometime if your starting torque is less than this, this is called as a magnetic alignment force. If it is high, then motor is failed to start. It will not rotate. So means your rotor is locked magnetically. That is called as a cogging or magnetic locking. Cogging or magnetic locking. Locking. So to reduce this, what we do first, this rotor slots, we not make parallel to this. Suppose this is the shaft, this is yours. So not we make like parallel this way, okay, like this. this way, not make parallel like this. Okay. Otherwise, they are face to face throughout the length of stator. What we do actually, we square at some angle like this, like this. We put like this, okay? Correct. So maybe at this end, suppose if they are, this is your rotor slots. Oh, okay. At this end, at both ends, they are short circuited also. So means throughout the length they are not aligned. It means we have weak. Means actually how we weak the magnetic alignment force between the stator and rotor. So means throughout the, suppose this is your stator. Now is if we make it, this is your one pole, suppose north pole of stator north pole. It is face to face with, but it is like inclined, na? Okay, it is not throughout the length they are parallel to. Then your magnetic alignment force is neutralize, reduce. Or other we see your number of stator teeth or slots equals to is actually is not equals to, is odd multiple of rotor teeth, rotor slots. Means not even, they are not even multiple. They are odd multiple, like 3 times, 5 times. Okay. Then there is a less chance they are face to face. Okay. This is the way. Now another one is, this is the cogging. Now come to the crowling. Crowling means the tendency of 3-phase induction motor continuously rotate at 1/7 of its synchronous speed, means very low speed, RPM, continuously, like crowling. Crowling means very slow movement. Okay. So it is the tendency of 3-phase induction motor to rotate continuously. Continuously means continuously at 1/7 of its synchronous speed, RPM. Okay. Means it not get accelerated, it achieve the high speed. So like to explain this crowling, we have taken a help of the torque versus speed characteristics. The torque versus speed characteristics of 3-phase induction motor has a dip. Sorry. Like this is your synchronous, means here is your synchronous speed. Okay. It is here n is 0. Here your n is equals to synchronous, like. So this is your, this way your speed is vary. Here is the torque is vary. Now you know this point. What is the speed at this? it is 1/7 of synchronicity. So it has a drop here, dip. Do this drop na, actually if not there, it will continuously move, like rise this way. But due to this na, it has a dip. Actually, this dip in the torque versus speed characteristics, in this characteristics curve, this dip is due to 7th harmonic. Now I tell you know, in what is the harmonic? Different frequency components present in your AC voltage, sinusoidal voltage. So if you know pure sinusoidal voltage waveform, pure sinusoidal, if you see, this is your pure sinusoidal AC. It has a frequencies. Suppose it is the frequency is fundamental. It is 50 hertz, means 50 cycle per second. So now we talk about the harmonic. Like first is your, it is a n equals to first. Second harmonic is 2. So actually odd harmonic not created trouble. Only, sorry, even harmonic. Odd are only we have to consider. Like third, first is the fundamental. It is the main fundamental. It is this. But third, fifth, then seventh. But higher order na, like ninth and above. Ninth and above we have neglect. Higher components we have neglected. Why neglected? I will tell you. Actually, if we talk about the nth harmonic. Next, so, what is the frequency of nth harmonic? If nth harmonic frequency will be n time of fundamental. Like if we talk about third harmonic, then what is the frequency? 3 times of 50. It is 150, my dear, hertz. So means, suppose in one cycle, your third harmonic will complete 3 cycles. Like 1, 2, 3, like it would complete the 3 cycles. 1, 2, and 3. Okay, in a one cycle, your third harmonic, and their magnitude is reduced, but magnitude is less. Okay. Now, if we talk about the magnitude of third, it is 1/3 of fundamental. Like we take like 230 volt RMS value or 415 volt line voltage. But this third harmonic voltage or current has a 1/3 of this value. Okay, dear. So this is the harmonic. So their frequency is increased, but magnitude is decreased. So now if we talk about the ninth and above, their frequency are very high, and their magnitude are less. So they have less effect. So we have neglected the higher order. Now we only consider up to 7. Actually, this third का हमारे पास treatment है, इलाज है. What we do, how we treat this? Because we control at the source end. Now, what is the sources of harmonics generally? Actually, your main source are alternator, transformer. Correct, na? Transformer. Okay. So actually, their core, they have a core, na, magnetizing core. So you know BH curve. You know BH curve. There is a non-linearity. It is saturate, na. So due to non-linearity of BH curve, it produces the harmonic. So your transformer and this alternator, it itself generates the harmonic. So now what we do have this alternator is connected through this, there is a transformer, then we get a step up, step down. But here, if it is a delta star, then your harmonics are circulate within the delta. They not come in the outside, so load side, load side. Okay, in delta connected or delta star like that. But in star connected, if there is no delta winding, then star connected three phase, we have another another third winding, that is called tertiary winding, to eliminate the third harmonic component. Okay, so we have to eliminate the third harmonic from the supply. Next is fifth is produce the negative sequence component. So due to negative sequence, negative direction your means field will rotate. So it will reduce your torque of the motor just. Okay. Or reduce the magnetic field in the air gap. Okay, so it reduce the torque basically. But seventh, due to this seventh, there is a drop here, it is a dip. Okay, so to eliminate, we have to either active filters to eliminate this hormones. But due to seventh harmonic, now if there is a seventh harmonic is present in your supply, like here, then this characteristics has a drop here. Now, if your motor is loaded, load is connected, mechanical load, then sometime now when we start the motor, it will accelerate and it continuously rotated this speed. It will not overcome, means not reach here. Actually, generally, these are the operating point of your motor. Means your motor is operate here. So this is your RPM. This should be your RPM. But when we accelerate the motor will pass through this curve and it will permanent. This is your full load torque. Okay. But it is rotate only here. It not get this speed. That is called crawling. Okay. So due to seventh harmonic component, there is a dip and it will rotate continuously at 1/7 of synchronous speed. That is called crawling. Got it? Already notes are put in group. Okay, go through this. Okay, dear, understand?
Yes sir. सर ये टर्सरी वाइंडिंग जो रहेगा ट्रांसफार्मर में रहेगा या मोटर वाइंडिंग में?
मोटर में नहीं, ट्रांसफार्मर में बताया ना, वो तो हम ट्रांसफार्मर जो पावर ट्रांसफार्मर होते हैं, अगर मान लीजिए उसमें स्टार कनेक्टेड है तो वहां पर एक और एक्स्ट्रा वाइंडिंग डाल देते हैं उसमें, थर्ड वाइंडिंग, दैट इज कॉल्ड टर्सरी वाइंडिंग टू एलिमिनेट द थर्ड हार्मोनिक कंपोनेंट. ओके, बाकी अदर रीजन है जो हार्मोनिक्स के रीजन है जो अदर क्या है, दैट इज व्हेन वी यूज ए कन्वर्टर्स लाइक your rectifier and like IGBT and this diode, HCR, thyristor, like. So we are chopping. It means after when rectification and like in VFD, we have to have a controlled converter. So basically we are chopping na sinusoidal voltage. Then we have get it again inverter. So actually we not get a pure sinusoidal. Even we use a pulse width modulation to make a pure sinusoidal, but there is a harmonics in that. So actually this is the disadvantage of your BFD. It introduce the harmonics. When that harmonics enter the motor, their motor losses are increased because high frequency component go na. So as I told na, your iron loss. हेलो, मोटर में जो आयरन लॉस होते हैं, कोर लॉस, दैट डिपेंड्स ऑन frequency, voltage and frequency. So if high frequency means higher the core loss. So due to harmonics component, they produce the losses, core losses. Then your motor heating also. So this is another region of motor heating. In your one question that is asked now, what is the causes of overheating, overload, harmonics present in supply, or either overload and under voltage also, because under voltage may motor draw the more current. Okay, that is called single phasing. These are the causes of overheating of motor. Okay.
Yes, sir. Thank you, sir.
Yeah. So this if there is a harmonics in supply, this is another reason of overheating due to because losses are easy. Now come to this questions, numericals. Okay. These are easy. Yeah.
Sir, in dry transformer, sir, that we use on board, that does not have any extra winding, right, sir, to reduce
Yeah,
harmonic.
because in on board we have a delta connected. No, does not required in, as I told in delta star also. If your transformer is delta star, does not require any additional winding. डेल्टा तो खत्म कर देता है अपने आप ही, उसमें क्या है, वो थर्ड हार्मोनिक्स विल नॉट कम हियर, they are only circulate within the delta. So if your transformer is star connected, then only we require a third winding. Okay.
Okay, sir.
Okay, so see, mostly this question you can easily do at 12th part B. Here slip is given. This is your output of motor kilowatt. Friction windage loss are given. Then you have to find the rotor copper loss and motor efficiency. If stator loss be also given. Okay. In 12B, just you draw the motor input. Then your stator loss. Yeah. After this, we get a rotor input. Then we have a rotor copper loss. Rotor copper loss. I am writing in short CR. CR is your rotor copper. PCR. Then this is your mechanical power develop. Then you have a friction and windage loss. And this is your motor output. Okay. My dear, here in your question C 12B, motor output is 36775 kilowatt is given here. Friction and windage loss are 3 kilowatt. So stator loss. This is 1500. This is 1500 watt, means 1.5 kilowatt. Then this plus this, we get here mechanical power. That is, if they add, no, 36.775 plus 1.5. 38.275 kilowatt. Now here this is 3 kilowatt total stator loss. Here slip also given. Slip given 4%. So now this we can calculate. Okay. So it is 38.275 divided by 0.04. kilowatt. Now this we can calculate. Hello, first part he asked so this. Okay, dear, this is the first part of question. Then you come efficiency. We calculate motor input P1. It is 39.869 plus 3 kilowatt. So we get a 42.869 kilowatt. Now motor efficiency. Output is 36.775. Input is 42.869 into 100.
$85.78.
Very good. 78%.
Is equal to
Okay, next.
rotor input minus mechanical 39.85 minus 38.275.
How much it is?
सर ये पीएम कहाँ से आया सर? पीएम मैकेनिक
PM इससे आता है ना, ये देखो दिस प्लस दिस करेंगे तो ये लैडर डायग्राम है. अब दिस प्लस दिस करोगे ये मिलेगा. दिस पावर प्लस लॉस इक्वल टू दिस. अगर जब डाउन साइड में आते हैं तो दिस माइनस दिस वी गेट ए दिस. भाई लॉस निकालते जाओ. इनपुट में से स्टेटर लॉस निकाला, यू गेट ए दिस. योर रोटर इनपुट माइनस रोटर कॉपर लॉस, यू गेट ए दिस. इफ दिस माइनस दिस वी गेट ए दिस ना. ये पार्ट निकलते जा रहे हैं. अगर जब आप ऊपर चढ़ेंगे, वी गो टू फ्रॉम बॉटम टू टॉप, देन यू ऐड दिस मोटर आउटपुट प्लस फ्रिक्शन लॉस, वी गेट ए ग्रॉस मैकेनिकल पावर. ओके, दिस
ओके सर.
plus this we get it. Okay, now I rough this because in same diagram we solve this 11th question. Okay, can rough this, Hiraj? Take a screenshot if required. Okay, now see. Okay, now next 11. If we see now here, we solve the 11 part. 11 question. Here a shaft output. Shaft output means motor output. So here it is given 80 kilowatt
Mechanical
of
50
three-phase
plus 0.920
60 hertz.
3.920. Okay, now mechanical में आ गए mechanical में
Please move now. This is 80 kilowatt. Now the Q friction and windage are 920 watt. It means 0.92 kilowatt. Then this plus this again we get here 80.92. Then this we can calculate how. And they see stator loss. Stator, you know, stator loss are core loss, means it is 4300 plus copper loss 2690. How much will this? 4300 plus 2690. Maybe this comes 6990 watt, or we can write 6.99 kilowatt. Now, my dear, here rotor current and rotor circuit as referred to stator side is given respectively. And you know, this rotor circuit parameter are given. They give R2 dash and I2 dash. It is 110 ampere per phase. Please, per phase. Always this is per phase. This is given 0.15 ohm per phase. Okay, rotor as referred to rotor circuit parameter as refer to stator side. That's why dash dash. Now if we calculate a rotor copper loss, then we can calculate 3 times of I2 dash square R2. Why it is 3 times? For total 3 phase. Okay.
सर इसका स्लिप दिया हुआ है तो डायरेक्ट भी निकाल सकते हैं ना?
हाँ यस, तो ये नॉट बट ये पैरामीटर नहीं है।
हाँ, इसको निकालने की जरूरत नहीं,
यूज करने की जरूरत नहीं है क्योंकि हमें स्लिप दिया है अभी डायरेक्टली।
P2 equal to PM upon 1 minus S.
Slip is 3.8% means 0.038. तो यहाँ पर हम डायरेक्टली we can calculate this is by. But if they here ask rotor copper loss, then you can solve by this method, okay? But here it is not asked, they only ask the efficiency. So we not required to calculate this. We directly jump from here to here, correct? So it is 1 minus mechanical 1 minus slip. So it is 8.92 by 1 minus 0.038. What is the value will come?
84.116. 84.116.
Okay, great. 84.116 kilowatt. Now from this will add, though we get a motor input will be, you add in plus 6.99. So it comes 91.106 kilowatt. Okay. Directly motor efficiency will be Output is 80. Input is 91.106. $87.8 है.
सर अगर रोटर कॉपर लॉस निकाल कर अगर सॉल्व करें तो सर
डिफरेंट वैल्यू आएगी. हाँ,
यस सर.
बट आप एक ही मेथड करना है कोई भी. है
नहीं सर, एग्जाम में जैसे अभी करते तो सर कोई दिक्कत नहीं है ना सर उससे?
नहीं है दिक्कत. आप इसी से कीजिए. ओके. नाउ ये जो क्वेश्चन है ना 10 is easy actually, but here data are missing. Okay, so we have to assume here in this 10. If you want, you take a screenshot of this 11. Please, I will again rough this data. Please. Okay, I will come.
सर ये R2 dash और R2 dash कैसा आ गया?
R2 and R2 days are given ना here. Question में लिखा है ना, देखो.
Yes sir, okay.
Rotor current and rotor resistance.
सर ये मोटर इनपुट का फॉर्मूला क्या था सर? P1 का स्टेटर लॉस प्लस
Stator loss plus rotor input plus stator loss, no? This plus this. Okay, downstream में जो power है, so here it comes ना P2 plus stator losses total है.
ओके सर.
Just a minute, I take a drink. I will take a water. Yes, please. Now we continue.
सर यहाँ पे जो फार्मूला आपने लिखा है जस्ट दैट कॉपर लॉसेस के लिए 3I2 डैश का स्क्वायर देन R2 डैश होगा ना सर वहाँ पे?
हाँ, ये R2 days.
ओके.
Please. Both are as referred to stator. Okay. Now we take another.
सर 2% का डिफरेंस आता है दोनों मेथड में.
रहेगा ही. Okay, dear. Now we come to here. Losses, ना? Now we come to this 10th question. A three-phase motor, three-phase, four-pole, when running with full four-pole induction motor. Actually, here frequency is not given, so you have to assume. Okay, frequency. Now he said that when it's running at full load, develop a huge full torque. Means it is a full load torque. So here 8, you write here 8 full load. At full load, motor develop T huge full. T huge full means actually it is a full load torque, shaft torque. That is 100 Newton meter. So here actually motor, here it is a now motor output we can calculate at full load. It is this much torque into mega motor output. But here huge full torque is given T huge full. It is 100 Newton meter. Now next he say that it is absorbed also. The rotor EMF is absorbed to make a 120 cycle per minute. Cycle per minute means actually frequency. It is a rotor frequency. The rotor frequency is given, my dear. It is how much? 120 cycle per minute. Generally we calculate in per second hertz. No? So if it is divided by 60, 120 divided by 60, it will get a cycle per second. So it comes 2 hertz. Correct, no? For cycle per second. Now let or assume F is the supply frequency. Okay, supply frequency. That is 50 hertz. We have assumed. Okay. Then rotor frequency by supply frequency equals to slip. Okay. So if your rotor frequency is given 2 hertz, this is 50 hertz, my dear, it comes 0.4 slip. Okay. We get a slip. Okay. When we get a slip, then we can calculate the motor speed, rotor speed. So your synchronous speed with 50 hertz 4 pole, it comes 1500 rpm ns into 1 minus slip. So this will come 1440. Please remember rpm. PM. Okay. For small n, we can calculate it comes 20 rps. Please. And synchronous speed will be your 1500 rpm. Or if synchronous speed in small, it is 25 rps. Okay. ये part आप रखिए याद. Okay. These are helpful. It is required. Okay, my dear. So one by one. First he asked, what he asked? Calculate the. Now he said that it is known that torque lost due to friction and core loss. So actually friction loss, so because as I told from here to here is a gross torque into omega we are taking. Here we take a shaft torque into means your full load torque into omega. So here is a difference in torque. The lost torque is lost. So T lost. T lost is 7 Newton meter. Then gross torque we can calculate. Gross torque will be your T lost plus useful output. It comes 107. Sorry. Your torque will be 107 Newton meter is your gross torque. Hello, please remember gross torque equals to T lost is 7 Newton meter. Okay, 7 Newton meter. Then therefore TG, gross torque. T useful plus T lost. Okay, please remember. It comes 107. Okay. This. Now, my dear, we can calculate. He is asked, what is the shaft power output means? Motor output, shaft power. So it comes your useful torque 100 Newton meter into 2 pi n. 2 into pi into n. N is 24. Please, you have to write this all. Now, mechanical power we can also calculate. Gross torque we take 207 into 2 into pi into again 24. Then this we can calculate because slip is given. Hello, please. So you know 2 into 4 into 24 into 100. My dear, it comes 15,072 watt. And this comes this will come 16127.04 watt. Okay. Now this we can calculate 10127.04 divided by 1 minus 0.04. Okay. It comes 6799 watt. Okay. Watt. Now here is a this efficiency. We let F equals to here I mean suppose F starter frequency we assume 50 hertz. Okay. Now my dear here now there is a one twist in this question actually. Actually this rotational loss also include the mechanical losses. Like here, this torque is lost due to this friction and core loss. Now in three-phase induction motor, core loss is only we consider in rotor, not stator. Rotor core loss are neglected, na? Now he asked the rotor copper loss also. So here you can put in second part rotor copper loss. So here you can write P2 minus PM. Okay, by this you can calculate. P2 minus PM. Okay, this process. Now, so already core loss we consider in the loss torque. Then only you can assume rotor copper loss here. Now, are you neglect or assume? See, your rotor copper loss will come, it comes 672 watt. Please, if you remember, na, this minus you have to subtract, na, minus 16127.04. It comes 672, correct? This load. Now, either you assume this starter core loss are 700 watt. Then this starter copper loss you can add here. So this come 16799 plus 700. Plus 700. It comes
सर 700 ही क्यों assume करना है?
वही तो एक प्रॉब्लम है. अभी मैं बताता हूँ what is the reason. Actually, core, copper loss or variable loss in motors, stator copper loss are 1/3 of, it is a thumb rule, 1/3 of total losses. There is a this, or actually it is like in rotor copper loss are almost 700, no, that's and in this problem actually it is assumed in your book, okay, where this it is taken. So you remember this in problem actually, or very simple, na, I will give the idea. You have to write here neglect the armature copper loss. हम neglect भी कर सकते हैं. Then only your efficiency will higher side. By neglecting the stator copper loss, then same this will be the same, na, here. Then you calculate the efficiency. But you write either you assume the stator copper loss or either you neglect the stator copper loss. Okay. Data is missing, na? They should mention stator copper loss. Okay, dear.
Okay, sir.
So mostly we cover the all most of question from your MET and your ETO. Okay. Just you prepare the theory part parallelly. Numerical, I take a guarantee. If new question will also come, na, you will solve. Okay. Now mostly we cover basic electrical like your RLC series parallel circuit. Then we cover the DC machine also. Here 3-phase. Now if we schedule a tomorrow class, only 2 hours we put. Okay. Then we start the transformer. So now transformer and synchronous machine are important. We cover, we have a time. Then we cover the power electronics questions also come, rectifier and this. Okay.
Okay, sir.
Yeah. So good night.
Good night, sir.
Good night, sir.
Okay. Welcome.
सर जो अभी न्यूमेरिकल सॉल्व की उसका एक फोटो नहीं
Yeah.
अभी जो न्यूमेरिकल सॉल्व की उसका
सर कल कितने बजे से क्लास लोगे?
मॉर्निंग में रख दे 7 to नो मॉर्निंग नहीं है, आफ्टरनून में रखेंगे 3 to 5 है. ओके.
ओके सर.
Yeah. Caulking is actually magnetic locking है. It is a